Alkenes. Alkenes have at least one carbon-carbon double covalent bond. Unsaturated alkenes are unsaturated, so it makes more bonds with extra atoms in addition reactions. Alkenes are unsaturated hydrocarbons. Two pairs of electrons with carbon-carbon double bond, high electron density, so reactive. So two reasons electrophilic addition reactions happen to alkenes. Double bonds open up, atoms are added to the carbon atoms. Happens because the double bond has plenty of electrons, therefore easier tapped by electrophiles. Electrophiles, electron pair acceptors. Examples, H+/NO3+, positively charged ions, or polar molecules where the delta plus atoms attracted to places with lots of electrons. Polar molecules, delta plus atoms attracted to places with lots of electrons. Carbocation, an organic ion containing positively charged carbon atom. Shaking an alkene with orange bromine water solution, and it quickly decolorizes bromine. Orange to colorless. Bromine is added across the carbon-carbon double bond to form a colorless dibromoalkane. Electrophiles, electron pair acceptors. Carbocation intermediate. The amount of each product formed depends on how stable the carbocation formed in the middle of the reaction is. Alkyl groups, alkanes with a hydrogen removed, CH3- methyl. Polymers containing electronegative atoms are polar, therefore have permanent dipole-dipole forces. So a key fact about carbocations and more alkyl groups, more stable as alkyl groups feed electrons toward a positive charge, therefore more stable carbocation, more likely to form. Alkyl groups feed electrons towards a positive charge. Polymers, long chain molecules, formed when monomers join together. Monomers, very small molecules, monomers join together. State three examples of natural polymers: silk, DNA and proteins, cotton and rubber. State two examples of synthetic polymers: nylon and Kevlar. And also, this is not an example of this, but hardening rubber is an example of modifying properties of natural polymers, therefore making it more suitable for car tires and cars. Additional polymers, when alkenes act as monomers and form polymers. When alkenes act as monomers and form polymers, double bonds open up and join together to make long chains. Say two key facts about polyalkene chains. Saturated molecules only contain single bonds in carbon chain, unreactive. Main carbon chain of polyalkene nonpolar. Longer the polymer chains and closer together they can get, stronger the van der Waals forces between the chains. Polyalkene chains non-polar, therefore van der Waals forces between the chains. Polyalkenes made of long straight chains are strong and rigid. Polyalkenes made of short branch chains are weaker and more flexible. Because remember, along the polymer chains close together, stronger van der Waals forces between the chains. Addition polymers made from alkenes are called polyalkenes. Polyalkenes, addition polymers made from alkenes. Synthetic means man-made. An example is polyethylene. Now, a key thing is that polyalkene chains, yes, they're non-polar. However, if it contains an electronegative atom, it becomes polar, therefore will have permanent dipole forces. But in this case, polyalkene chains are non-polar, van der Waals forces between the chains. Say two things that happen when you add a plasticizer to polymer. Plasticizer molecules get between the polymer chains, pushing them apart, reducing the strength of intermolecular forces between chains. Therefore, they can more slide around, more easy to bend. Say uses of rigid PVC: make drain pipes and window frames. Say the uses of plasticized PVC, which is more flexible than rigid PVC: make electrical cable insulation, flooring, tiles, and clothing. PVC has long, packed polymer chains, therefore hard but brittle at room temperature. Repeating units. A bit of a molecule that just repeats over and over again. Polymers are made up of repeating units. Stay how to draw the repeating unit of a polymer made from monomer. Probably better if I did an example, but I was doing this during my free period, so I wanted to go through all the key points. So we need to draw two alkene carbons, then replace the double bond with a single bond, and then add a single bond coming out from each of the carbons. Say how to draw a repeating unit for polymer, for addition polymer. Work out part repeating a chain. Work out the part that's repeating chain. For addition polymer, the repeating unit should be 2 carbons long. Then draw the monomer by adding a double bond. Stable alcohol being primary, secondary / tertiary depends on which carbon atom the OH is bonded to. Elimination: a small group of atoms breaks away from a larger molecule and is not replaced by anything else. Making alkenes by eliminating water from alcohols in a dehydration reaction, aka elimination of water. It allows you to produce alkenes from renewable resources, therefore producing polymers without needing oils. Alkenes are used as starting materials for polymers. Here's the equation: CnH2n plus 1, CnH2n plus 1 OH, arrow CnH2n plus H2O, C2H5OH, arrow H2S4, C2H4 plus H12. Ethanol is heated with concentrated sulfuric acid catalyst. Product, however, is usually in a mixture with water acid reactant, so the alkene has to be separated out. Dehydration, alcohols to alkenes. While it contains a mixture at the end, contains a product, reactant, acid, and water. So therefore, we need to purify this using distillation. And distillation uses the fact different chemicals have different boiling points to separate them. Ethanol produced by hydration of ethene by steam. Ethanol produced by hydration of ethene by steam at 300 degrees Celsius, 60 atmospheres of pressure, needs a solid phosphoric 6 acid catalyst. CnH2n plus H12 reversible reaction H plus CnH2n plus 1 OH. Standard industrial method for producing alcohols. Hydrating an alkene using steam in presence of acid catalysts. Alkenes again. This case, fermentation, an exothermic process carried out by yeast in anaerobic conditions without oxygen. Exothermic process carried out by yeast in anaerobic conditions. C6H12O6 aqueous, arrow 30 to 40 degrees Celsius. Yeast 2C2H5OH aqueous plus 2 CO2 gases. Yeast produces enzyme converting sugars. Yeast produces an enzyme converting sugars, aka glucose, into ethanol and carbon dioxide. Enzyme works at optimum temperature 30 to 40 degrees Celsius. Then the ethanol is separated from the rest of the mixture by fractional distillation. Evaluating fermentation is low tech, uses cheap equipment and renewable resources, but fractional distillation step to purify ethanol, extra time / money. But the advantage is low tech, uses cheap equipment and renewable resources, but fermentation, ethanol needs to be separated by fractional distillation step and fractional distillation step to purify ethanol, extra time / money. Biofuel, a fuel that's made from biological material that's recently died. Biofuel, a fuel made from biological material that's recently died. Evaluating biofuels. Biofuels are renewable energy sources. They won't run out and they're more sustainable. Biofuels, however, do produce carbon dioxide when burnt. However, the plants absorb this carbon dioxide produced while they're growing. Therefore, it's still considered carbon neutral, because even though biofuels do produce carbon dioxide, the plants absorb this CO2 while they're growing. Therefore, it's still considered carbon neutral. One problem switching from fossil fuels to biofuels in transport is that petrol car engines have to be modified to use fuels with high ethanol concentrations. 6CO2 plus 6H4, arrow C6H12O6 plus 6O2, C6H12O6, arrow 2C2H5OH plus 2CO2, 2C2H5OH plus 6O2 to form 4CO2 plus 6H2O. Memorize these three equations. Obviously, all these equations I put throughout this video on the piece of paper. You do need to memorize it. This one I've seen on AS level paper. I think it was 4 marks. 3 marks for literally just copy and pasting these 3 equations. And then 1 mark for what I'm going to talk about now. Is it actually carbon neutral? This idea of, is it carbon neutral or not? Well, 6 moles of CO2 is taken in, 6 moles of CO2 given out. However, fossil fuels need to be burned to power machinery to make fertilizer for crops. Fossil fuels need to be burned to harvest crops and refine / transport bioethanol. Fossil fuels need to be burning fuel to power the machinery / which produces carbon dioxide. State the simple way to oxidize alcohols by burning them. And so yeah, with that 4 markers, about the AS question about ethanol, you'd copy and paste these equation and you'd talk about it's not actually carbon neutral, even though 6 moles of CO2 taken in, 6 moles CO2 given out. You just use one of these points. Fossil fuel burn to power the machinery to make fertilizer for crops, for example. So the simple way to oxidize alcohols, burning them. We need to use the oxidizing agent, but that's not the way we use it in chemistry, because that's not really exciting. We need to use the oxidizing agent K2CO2O7 to mildly oxidize alcohols. Cr2O7 2 minus is reduced to Cr3 plus iron. Orange dichromate 6 iron is reduced to green chromate 3 plus iron. Primary alcohols oxidize to aldehydes and carboxylic acid. Secondary alcohols oxidize to ketones only. Tertiary alcohols unoxidized. Aldehydes have a hydrogen and one alkyl group attached to carbon atom. We don't need to say which carbon the functional group is always one. Ketones have two alkyl groups attached to carbon atom. Ketones with 5 or more carbons, we have to say the carbon the functional group is on. Aldehydes / ketones are carbonyl compounds. The functional group is C double bond O, and the general formula is CnH2nO, the general formula of aldehydes / ketones. R-CH2-OH, primary alcohol plus O, RC double bond OH plus H12. Primary alcohol, and this represents oxidizing agent, plus oxidizing agent aldehyde plus H12. RC double bond OH plus O, arrow reflux to form RC double bond OH. This case is your aldehyde being oxidizing the aldehyde with reflux, that's really important, to carboxylic acid. Refluxing a secondary alcohol with acidified potassium dichromate 6 produces a ketone. R1-CR2HOH plus O, arrow reflux to form R1R2C double bond O plus H12. R1CR2HOH plus O, arrow reflux, R1R2C double bond O plus H12. The only way to oxidize these tertiary alcohols is by burning them. So we don't, because if we use this, it's not going to work. Failings and Benedict solutions are both deep blue Cu2 plus complexes and are reduced to brick red Cu2O when warmed with aldehyde, but they remain deep blue. Ketone stays blue because there's no effect on ketones. Tolerance region Ag bracket NH32 positive charge, reduced to silver when warmed with aldehyde but not with a ketone. The silver coats the inside of the apparatus, forming a silver mirror.